Hi everybody, Keith Tanner here from Flyin Miata, and today we're going to talk about differentials. Not pressure differentials, which I have a tendency to rattle on about every time there's a chance, but actual differentials as you will find in your axle. Now we are doing this live on Facebook Live. If you have any ideas for future topics, things you want to see us cover in these videos, technical ones or otherwise, put them in the comments. Let us know, because we're always looking for interesting ideas to do this. We do a Facebook Live every week, and well, there's only so many things to talk about. So if you have any great ideas, anything you want us to cover in these sessions, in these videos, definitely drop them in the comments. Let us know, because we're always looking for good ideas. So today I'm going to talk about differentials. Now, the purpose of a differential is to let cars go around corners. And I have brought my little friend along here. Let's pretend this is one of Mazda's DP1 race cars. But when you're going in a straight line, your wheels are all moving at pretty much the same speed. Fair enough. We don't need to do anything with differentials at that point. But when we're going around a corner, the inside wheels go a much shorter distance than the outside wheels. The tighter the corner, the more extreme this is. And this is just simple geometry. So in order for the inside wheels or the outside wheels to go further over the same amount of time, they have to turn faster, which means that you've got your inside wheels and your outside wheels turning at different speeds. And so you need something to allow that to happen. And that's what a differential does. Flip this guy over. And this is actually a pretty decent little model. There's our differential in there. And that allows our wheels to move at different speeds. You can see I'm being fairly extreme here. But that's the entire purpose of a differential. If you don't have one, what happens? Both wheels always turn the same speed, and then when you go and try to go around a corner, the inside wheel will be pushing. It'll be trying to go the same speed as the outside wheel, and that will drag the car effectively straight. The car will resist turning. Go-karts don't have differentials, for example, and one of the ways to make go-karts turn is you got to sort of unload that inside wheel. I believe that's the case with four-wheeler ATVs as well. Not being an ATV rider, but I believe that is the case. You got to unload that inside wheel. I'm sure there's ATV experts out there who will tell me if I'm right or wrong about that one. So that's why we have differentials. But there's a bunch of different kinds of differentials. The problem, the most common kind of differential is one like we have here, which is, I'll flip this back over, which is an open differential. And this little Lego model is actually a pretty good example of how they work. These are called spider gears, these three little tan gears in there, and they allow, well here I'll drive the engine, they allow the car to go like this, and then one wheel can move slower than the other one, it can actually stop, and the other one will keep going. This is called an open differential. And it's the least expensive one to make, it has the least effect on handling in terms of it's basically invisible, but the problem is that the power, the torque, gotta watch that one, the torque is delivered to the wheel with the least traction, basically. So if you, is that the way to put it? I think it is. Delivered to the least traction. So if you are going around a corner and you have all your weight transferred to the outside of the corner, so your inside wheel goes light, it's possible that wheel will take more torque because it's easier, and so therefore you'll spin your inside wheel and you won't accelerate out of the corner. Or if you're stuck in a snowbank, you get one wheel gets jammed in place, the other one just starts spinning uselessly, you're not going anywhere. If you're off-road, same deal. So what we need is something that will allow torque to be delivered to the other wheel when one wheel is just not able to get the job done because it doesn't have any traction, it's up in the air if you're an off-roader, whatever. So that's where we want something that has a limited amount of slip, a limited slip differential. There we go. So there's a bunch of different kinds of limited slip differentials, and that's what I'm going to talk about, is what the different kinds are and what you can expect from them. When we asked for comments for questions for this video, most of the questions we got were actually about gear ratios, final drive ratios. And the reason for that is because, we'll look over here, this is a differential out of a Miata, sort of, but the differential is inside the ring and pinion, and this is your final drive. So a lot of people consider this to be a differential. So it's got the gear ratio in it as well. They're really two separate things. You can change one without changing the other, but then you have to set the gears up. It's more complicated. So most people will just see if they can grab a chunk like this and swap it out. And that's why gear ratios are so tied up with differentials, because they very often end up dealing with the same thing. So I am going to talk about gear ratios a little bit. I'll do it later on. I'm going to cover the differentials first. So if you are watching this live, please fast forward another 15 minutes, and I will get to that. And as always, if you have questions, throw them up in the comments. Travis will let me know what they are, and we'll hopefully answer them. So let's talk about our different kinds of differentials. First one is an open differential, which can deliver up to half of the available torque to one wheel. And then or to both wheels, basically. It'll split them evenly, or it'll just blow everything out the one wheel that has no traction. The other sort of most obvious one to understand is a spool, which is basically no differential at all, which means that both wheels get the same amount of torque all the time. That's what Porsche used in the old 956, 962 Le Mans winning race cars, and I think the reason for that was because of a broken axle they could get back to the pits. Very important to Formula One, because in one of these things, if you break an axle, then you just spin the wheel, it's missing the axle, you don't go anywhere. But it has real effects on handling. We have done this on a Miata. We have built a Miata with a spool in the past. The thing was brutal in the pits. It worked okay. You could get it to work on the track, but it required a very specific kind of driving style, and it had a tendency to understeer. Didn't like turning into corners because those rear wheels wanted to just drive it forward. And you don't want to do this on front wheels. On a front wheel drive or a four wheel drive with a locker or with a spool in the front, the thing is never going to go around the corner. That's it. You're going straight for the rest of your life. So a locker is basically a spool that can be turned on and off. You don't see them in Miatas. You see them in Jeeps, which is basically ARB makes them for Jeeps and Land Rovers and stuff like that, where you flip a switch, it turns your rear wheels into a locker, and that way, no matter what you do, you're going to have torque going to both wheels, and you will climb up that rock. You don't put them on the front wheels because, again, you're just going to go wherever the nose of the thing is pointing, but that is a pretty crude but very effective version if that's what you need. Now, what we find in Miatas, there's been a couple of different kinds. I forgot to write this one down. I'm going to go through the Miata options, not quite chronologically. The most common one, the one that people know the most, maybe not most common, is called a Torsen. And that's a helical style differential. And if you want to zoom in here, Travis, this is a helical style. It's not actually a Torsen, but if you peek in through this case, this is a Guru, by the way. This is an Australian-made Diff that's no longer around. Immensely strong. But you see these little worm gears. Torsens work on the fact that worm gears can transmit power one way but not the other, with a lot of sprinkling of black magic. I'm not going to try to explain how they work because, for one, I'm not 100% sure I have all the black magic figured out, and there's probably like an engineering explained video or something out there that shows them with great 3D models and stuff like that. I don't have those, but basically they rely on the worm gears. And they're very long-lived. And one nice thing about them is that they don't affect the turning of the car very much. It's one of the reasons Mazda used them. They still give a very pure sort of steering feel. The differential doesn't fight the steering as much. The thing about a Torsen, though, is that basically the torque it can deliver to the wheel with traction, without traction, is a multiplier of, this is really easy to get tangled up in this. Basically, it can only transmit so much torque from one side to another, and it's a multiplier of how much torque is available. So if you have a wheel that's extremely low on traction, and you can only put a little bit of torque through it, you're only going to be able to put, say, that amount times 2 to the other wheel, and that may not be enough for you. If you're stuck in a snowbank, if one wheel is spinning like crazy, the Torsen will not be able to put very much in the other wheel at all. If you're on the racetrack and you have a whole lot of horsepower and you're having say you hit a curb and you spin up that inside wheel, you might lose drive on the outside wheel because there's just no multiplication available to you. And that's why, actually, if you're ever stuck in the snow and you have a car with a Torsen, dragging the brake can help. Putting on the handbrake a little bit, because that gives a little more torque to the wheel that's freewheeling effectively and transmits some to the other side. It's kind of it's a trick you can use off-roading. It's unlikely to have to use it in Miata. You're not going to use it on the track for sure. But the nice thing about Torsen is they're durable, they're strong. They don't wear out over short periods of time. They do wear out on extremely long periods of time. NA Miatas, their Torsens, if they're seeing a lot of hard use, may be starting to show trouble because there is some little clutches in there, some little preloads I didn't even know about until just recently. But generally speaking, they don't need any maintenance. They don't need special oil. They don't need anything special with them. In 2001, I think it was, Mazda went to the Tojiki Fuji Super LSD, which is a great name. And it's It's sort of a clutch type disc differential. I'll get to that. It uses cones. It doesn't have a lot of the characteristics of a clutch pack. It actually acts more like a Torsen in terms of its behavior. So generally speaking, I don't treat them much differently. They're both very, very long-lived. The way that those clutches work, they're almost immortal. And personally, I don't really consider them to be a whole lot different. I'm sure there's probably someone out there who's a differential specialist whose head just exploded, but fundamentally, in my experience, they haven't been that different. So what is different is a clutch pack. And this is something, if you know what a posi traction is, that's a clutch pack. This is a far more common, it's an older limited slip differential. The Torsens showed up, I think, originally in the 80s, late 80s, early 90s or so. They started showing up the first. Before that was all clutch packs. And a clutch pack is exactly what it sounds like. In between the two axles, you've got clutches. And they will basically stay stuck together until they start to slip. But it's the friction between the two of them. That's what delivers more torque to the other wheel. So they're fairly simple to understand. They do rely on special fluid because it's got to have just the right level of friction in a clutch pack limited slip. If you don't put the right kind of fluid in, you can end up with it grabbing and releasing, grabbing and releasing. That's how I found out I had a clutch pack limited slip in my old school Land Rover. Very rare, it turns out. I put regular fluid in it, and all of a sudden it started chattering all over the place. So we took it apart to find out what was going on. I was like, oh, surprise. No Miatas were ever delivered from the factory with one. I think there's a Mazda Speed version out there. Kaz made some. There certainly are some options out there, but factory units, there are no pure clutch pack factory differentials in Miatas. There's a variant on that called the OS Giken that's very popular in Miata circles. Flyin Miata happens to sell them. Very effective at putting power down, and they're basically a clutch pack, but they have a lot of clutches. So instead of being one or two big clutches, it's got a whole stack of them in there. And the idea being there is that its release is a little more gradual. It doesn't sort of let go quite as quickly when the clutches do start to slip, and it's more durable because there's a lot more friction surface in there. So you're less likely to overheat and start wearing out those clutches. Clutch pack stiffs do need occasional replacements of the clutches. Exactly how much depends on how much you've been abusing them, the more you've been forcing them to do work. But they will need, they do need more maintenance, more care. As for the OS Giken, the clutch packs, because they have a tendency to, they want to drive that inside wheel, they will give you more understeer on corner turn in, but they will give you much better exit speed, exit acceleration out of the corner. Especially if you've got one wheel that's unloaded, light because you're still loaded, you're still cornering, you've got that inside wheel, it doesn't have a lot of weight on it. Something like a Torsen can, especially on a high horsepower car, can just burn up that inside wheel, whereas the Giken or a clutch pack will drive both of them and get you much faster off the corners. I tried an OS Giken in this car years ago, took out a factory Torsen, put the OS Giken, not when it was a V8, it was a 4-cylinder, and it was worth, I think it was 1 second a lap on our local go-kart track, which is about a 63-second lap at that point. So that's a pretty significant difference. There was a difference in it. I didn't change the tuning of the suspension for that, so it did have some turn-in understeer, especially on a track like that with lots of tight corners. That was a problem, but the extra drive off the corners was so dramatic that it cut a full second off my time there. Do we have any questions, Travis? Yes.
Sure. The first one is, can you describe the symptoms of a worn-out diff?
Symptoms of a worn-out diff. Well, it depends on, I guess, which part of the diff we're talking about. Usually when people are concerned about a diff being worn out, it's actually the bearings. It's not the differential unit itself. It's the bearings or the ring gear, and so you get a lot of rear-end noise, a lot of chunks coming out of it. That's sort of, it doesn't really affect the driving experience per se. Now, if it's a clutch pack that's worn out, well, at that point, they're just going to slip more. You're just not going to be getting that drive off the corners that you're supposed to. It's just going to slip more and more and more, just like a worn out clutch in your transmission. So that's what the driving experience feels like, is just your limited slip is not limiting the slip as much as it should be limiting the slip. This thing has a limited slip now, and I've got to tell you that it's very effective at getting the power down out of corners, far more than you would think a 500 horsepower car with 225 should be. Because of the very, very good limited slip, clutch pack limited slip that's in the rear end. But it does a lot of abuse on that particular limited slip, so it's not going to survive forever or very long, really. We had more questions, Travis.
Yes, we do. I guess I'll just go down the line.
Let's go down the line.
The next one is, what do you recommend for differential bushings, and what difference will they make?
Differential bushings. Okay, so the question is, what do I recommend for differential bushings and what difference do they make? And now, this is a very Miata-specific question. Well, mostly. Because this, on the NA and NB, this differential unit is mounted in almost like a T-shaped, I don't have one here to show, but a big aluminum housing that's got big arms going out this way. And that's part of how the Miata sort of suspends its entire drivetrain with the power plant frame. That's a fairly major mount point. And those bushings allow the differential to rock a little bit because it has to. If they move too much, you can get into points where you get that classic 2 to 5 shift. You know, you're going for 3 and all of a sudden the whole thing rocks over and 5 is where 3 used to be. That's where you get some benefit from the stiffer bushings. In theory, it should help with wheel hop a little bit, which is the wheels hopping up and down, although I tend to focus more on bushings in the suspension and shock absorber settings for that. You will find if you go for stiffer bushings or even solid inserts that you will get a lot more noise, vibration, and harshness, and you're also more likely to break the arm off one of those differentials if you go for a really, really stiff mounting on them. It takes a lot of abuse to do that, but it can be done. We had a third one, right, Travis?
We have more.
We have more.
Next is, how can you tell if you have a Torsen or what kind of diff you have in your Miata without taking it apart?
How can you tell if you have a Torsen or what kind of diff you have without taking it apart? That's not easy, actually, because Torsen's, the classic test for limited slip is to put the car up in the air and turn one wheel one way, and if the other wheel goes the other direction, that's an open differential. If the other wheel goes the same direction, that's a clutch pack differential. Problem is, Torsens act exactly like an open differential when that happens. They turn backwards, so you can't do that. And there's no external signs for it either. So you can't from just inspection. You can check by driving, put one wheel on a lower traction surface and the other wheel on a higher traction surface and give it some gas. And that is a test for any limited slip, because if it cannot transfer torque to the wheel, it's got that's actually got the grip, it's not just burning out, then it's not working as limited slip. You can tell from visual inspection if you take half shafts out, and there's actually a good spotter's guide on Miata.net called the Differential Spotter's Guide, of all things, that talks about the different variations, and you look through. The biggest thing is an open differential like this will always have a crossbar running through the middle, because the one difference, this only has one spider gear over here, it should have one on each side, and there's a shaft that joins that. So if you look through the center of the differential, on an open, you will have a crossbar in there. This has no crossbar, so it's something else. And in this case, it is a Torsen. The Fuji's, the Super Diff, I believe has a visible cross shaft in there as well. So check that spotter's guide. That's what I would go to if I was wondering. Travis, another question.
How do the clutch type diffs operate with one wheel off the ground?
How do clutch type diffs work with one wheel off the ground? They actually still work quite well, which is why they work pretty well in off-roading. Basically, because of the internal friction, they will always transmit some torque to the loaded wheel. You know, the wheel has got some grip, so it's going to be hard on the clutches. You know, that's when they're working, that's when they're slipping, that's when they're making some power. But that is their intent. Is if you do have a wheel with absolutely no traction, they should still put some to the other side. That is the goal. It's one thing to know about a clutch pack diff is if you are running with a degree of slip for a long period of time, like say you have a flat tire and you put your run flat on and it's a slightly different diameter, or your spare tire, if you go like that for a long period of time, you will burn up those clutches because they are constantly slipping, even just going down a straight line. So you have to be careful if you're doing that. If you have a clutch pack diff in there, you have to make sure your tires are the same diameter. Interesting fact with a Torsen, if you have wheels of different diameter, it'll actually pull to one side. It'll actually, I forget which way it goes, but under power it'll go one way. As soon as you let off the gas, it'll go the other way, and that's it transmitting its torque, sensing the torque delivery and shifting it back and forth. Kind of fun. Do you have another one there, Travis?
This one's specific, and it should be in your notes, but someone is asking if a Indy Club LSD will work in his 2019 RF because Mazda won't sell anymore.
Yes, that question is here. The question is, for those of you, if you couldn't hear it, let me go down here. 2019 RF manual. Can he put a club, the limited slip that's available in the club pack or the GTS, can he put it in his car? And yeah, it should be a straight drop-in. Dealers will be hesitant to do that because you're modifying a car at that point, and if anything goes wrong with the driveline, it will probably affect your warranty. It won't, affect the warranty on your power windows, but if your transmission blows up and you've changed the differential, that might be a little bit of tap dancing when you're talking to the warranty department. Maybe, maybe not. It shouldn't blow up your transmission, although it does give you more traction. But that's why you will find that dealers will probably be hesitant to do that sort of thing, but it is literally a bolt-in. Okay, so I haven't really finished going through all of these different kind of differentials because there's another one we haven't mentioned, and that is the viscous LSD that's in the 1.6 cars. The Torsen didn't show up until the 1.8, it's 1994. Before that, there was something called a viscous, which is not well regarded in Miata circles. And the viscous is kind of like a clutch pack in terms of it's got discs inside a fluid, but they don't touch each other. But what happens is the slippage, if you get one wheel going faster than the other one, they're moving relative to each other, and that thickens up the fluid, and that starts to transmit power to the other side. They don't burn out the way that clutch packs do. They kind of sort of work like a clutch pack, but only once they get warm. And they can have some unusual behavior as the temperature gets up to temperature, and then it gets too hot. And they never did a lot of torque distribution anyhow. Their torque distribution ratio side to side was never all that big. You had to slip them for a certain amount of time before they really started working well. So they've got a poor reputation. They're better than nothing, but because they were usually wrapped in the smaller ring and pinion, a 6-inch ring and pinion, I think, they're not as strong to begin with, and so they're not a very desirable differential for a lot of people. They're very long-lived. People think they're dead all the time because they just don't transmit that much until they've been worked hard. But the fluid that's in them is separate from the fluid for the ring gear, so it's actually got its own little container of fluid in there, like this thing was a solid piece. So it's better than nothing, but most people will grab a Torsen out of a later car because of its extra strength, because of its extra durability, and because it's a fairly easy swap to do. Travis, you're making faces, so we must have an interesting question.
This is an interesting one. Which differential has the greatest amount of parasitic drag and will eat up the most of your horsepower?
Which differential has the greatest parasitic drag and will eat up the most of your horsepower? I don't know, honestly. That's an interesting question. Yeah, that is a really interesting question. Straight line doesn't really matter because it's all just the ring gear. The differential, the internal parts are not moving relative to each other. The way I look at that sort of question is make sure the differential is distributing the torque the way you need it to first. Having a differential that doesn't let you put the power down but doesn't use as much power is not useful. Not as useful as a differential that will put the power down better. Does that make sense? I think it does. So that's an interesting question. That would be a really deep dive, like, when you're in your third year engineering class, put your hand up in the air and ask your mechanical engineering teacher that one, because that I would love to know. If you do find out, put it in the comments. Travis, another one.
This one's also in your notes, but someone's asking if FM will ever offer Torsen rebuild kits in the future.
The question is, will FM ever offer Torsen rebuild kits in the future? And I have to admit, I didn't even know until recently that they could be rebuilt, that there was anything that needed to be rebuilt, because there is some little bit of preloading on the ends of those worm gears. And they are very, very, very long-lived. Yeah, this is not a factory Torsen, so it doesn't help you very much. But they're extremely long-lived, so it's one of those things where, spec Miata racers after 10 years are starting to notice the difference. Will we? Perhaps. I don't see why not. It's not something that's currently on our list of products under development, but I don't see any reason why we couldn't. So there's a solid maybe answer for you. Travis, another one.
Do you know the differences between the Type 1 and Type 2 Torsen differentials?
Oh, Type 1. The question is between the Type 1 and the Type 2 Torsen differentials, and it's got to do with the way, if I remember correctly, it's got to do with the way the worm gears are laid out. One of them, they're parallel like this. Another one, they're parallel. They're perpendicular to the half-shafts. I believe that's what it is. Functionally, they're very, very similar. Not enough to be too excited about. But yes, there are two different kinds. I think the Type 2 came out in 96 in the Miata, and the Type 1 was used 94, 95. Again, it's one of those things where functionally they're not radically different, so I've never paid a lot of attention to exactly what's going on with how the worm gears work. So yeah, there's actually some interesting reading to be done there. Torsen, by the way, stands for torque sensing. It's a cool little name. I remember them first showing up in Audis. in the Quattros, but it's actually a brand name. The generic name is helical. So a Quaif is a helical style, this Guru is a helical style, and Torsen is a very specific helical style. So we tend to use Torsen in the Miata world because that's what the Miatas had, but it's actually a little more generic than that. So those are my different types of differentials I've had so far. Let me do a quick check and have a look at what questions you guys have sent in earlier. One question we did have earlier about spotting Torsens. And the question was about spotting Torsens, but spotting limited slip differentials in general. The one nice thing about the viscous limited slip differential in the 1.6 is it is visually different. It has different size stub shafts on each side. And the flange on the stub shaft is a two-piece half shaft. The flange on the stub shaft is different on the left side and the right side. So if you have a 1.6 and you look underneath and you see those bolt-on flanges on the differential, if they are different side to side, that's a viscous. Smooth case, fin case, doesn't matter. That's just a production error time. But that's the only limited slip you can spot from outside on the Miata. Travis, another question.
Have we ever broken a Torsen?
Have we ever broken a Torsen? No, we have not ever broken a Torsen. Torsens are pretty strong. You can break a ring gear if you try hard enough. We have never broken a ring gear. The best way to really break a differential is going to be shock loads, which means wheel hop, which means, as far as I'm concerned, poor suspension tuning. I know we've got customers that have broken them in the past, 400 plus horsepower turbo cars. And I believe in one case, Andrew Searle, I think it was, might have been Steven. I think he went with a Guru, one of the last Gurus that we had. I think that was his solution for that problem. But it's pretty hard to break one. It's the one thing you can break, and the most common differential failure in Miatas is probably those 1.6 ring gears, because they are smaller, they are weaker than the ones used on the later cars starting from 94. And with enough abuse, you can break one on a stock engine Miata. You have to abuse it. You can also run turbo cars for years without breaking it. So it depends on those shock loads. But if you're dropping the clutch you're kicking the clutch to get the back end out, or you're revving to 7,000 and dropping the clutch for drag starts, especially with a wheel hop, that's when you're going to start busting stuff up in the rear end. We have another question there, Travis?
Ooh,
You can see the look of concentration in your face. You're trying to read as I'm talking here because they keep going past pretty fast.
So someone is considering his Fuji with a Torsen, come back, with the same gear ratios. Will he get any performance gains, and is it worth it?
Okay, so the question is, and I'm not 100% sure I got this right, but someone is considering replacing his Super LSD with a Torsen, but with the same ring and pinion gear ratio, and will he see any performance increase? It's going to be subtle. It's going to be subtle if there is a performance increase. I must admit, I'm not deep enough into exactly how much power you can put down with these kind and how they work if you're lifting wheels in the air. I do know if you are having trouble getting power down because you're lifting, your inside wheel keeps spinning, you're probably better off with the Fuji because it's got a little more preload to it than the Torsens do, and they're less likely to go open under those conditions. Clutch pack will completely solve that problem, but I think the Fuji will be slightly better in that regard. Let me just do some checks here. Okay, now, do aftermarket limited slips make sense for people who track their cars? And this is what it really comes down to, is like, what kind of differential do you want in your car? Torsens are great for everyday use because they just plain work. They don't cause that turn-in understeer. One of the fun things about a Miata is how they really do turn in nicely. And you don't get with the Torsens, you don't get the car trying to push itself straight forward that you get with a clutch pack. But in my experience, as I mentioned earlier, the ability of a clutch pack to put down the power no matter what makes it a better track tool. And that's why you'll find autocrossers, you'll find a lot of Miata racers, where they're allowed, will be running the OS Gikens because they have that ability to really, really put down power no matter what's going on with the inside wheel, no matter how little weight it's got on it. You can still power the outside wheel, which will help you get around the corner and will also get you out of the corner. Travis, do you have more questions there?
Some of them you have there. First question. This person heard that an RX7 NA diff cover will bolt onto the 7-inch housing. Is the inside of the cover the same shape as the stock cover, and without oil flow effects?
Okay, so the question is about using the rear cover, the housing, for an RX7. I'm not sure which generation RX7, probably an FD, I'm guessing, but I don't know for sure. I have not experimented with the RX7 swaps, with whatever parts you can transfer from those. So I don't know. And the question is specifically about oil control inside. I don't know about that. I'm afraid it's not been a problem for most of our differentials. They seem to stay lubricated. We have not experienced any real problem with them experiencing lubrication-related failures. The biggest thing on the ND, of course, is that it's got such a small amount of fluid capacity, and that's why we offer coolers for those to keep that fluid cool and to add some extra capacity. But that's not what we're talking about with the RX7. I don't know if you can bolt an RX7 part on, and I don't know what advantage it has, so I'm no help there. Travis.
Have you ever used a Mazda competition clutch diff in a 1.6?
Have I ever used a Mazda competition clutch diff in a 1.6? Now that's a clutch pack, and that was an optional upgrade or an available upgrade. Obviously, pseudo aftermarket. Mazda competition being something you didn't get off the showroom floor, but you could buy through Mazda. I have never used one on a 1.6 because that was a fairly short-lived product as far as I'm concerned. If you're allowed to change to a 1.8 diff, why don't you use a 1.8 diff? Because you get that stronger ring and pinion and a greater selection of ratios. So as far as I'm concerned, that's more of a, kind of like a stroker kit for a 1.6. It's kind of like a historical oddity. But unless you are constrained by class rules, I would be going up to the 1.8 size no matter what, simply for strength. So I have never experienced, I've never played with one. So Travis is trying to scroll through all the questions. We got a lot of questions today.
A few. So this one is in your notes. I'm sure I sent it to you earlier.
Yeah, I have so many questions.
Is the customer who's talking about what he can change without an indicator clock and what the torque specs should be. I don't know if you want to get into that.
Yeah, the question is basically what parts of the differential can be serviced without having to get into the difficulty of setting up a ring and pinion. So I'm going to use that as an opportunity to start talking about ring and pinions. Because like I said, a lot of our questions about this thing were about ring and pinions because a lot of people, that's what they focus on. They're looking at getting one of these things out of a junkyard. If you find a guru in a junkyard, good job. There's probably a dozen of them in the US at most. But, buying this one piece and bolting it in. And the reason you do that is because it is literally a bolt-unbolt solution. If you have the housing, then, heck, you can do it relatively easily. Just a little bit of screwing around with half-shafts and power plant frames. But generally speaking, you don't need any special tools. It's about as complicated as doing a clutch. But that also opens up the possibility of interchanging the ring and pinion ratios. And so why would you want to change the ring and pinion? And I will get to that question about the seals and what you can change with an indicator. Why would you want to change the gearing ratio? Well, it depends on what you're using the car for. If you are doing a lot of interstate trips, spending all your time at 80 miles an hour, you probably don't, that is the legal speed limit in Utah, you probably don't want the 4.3 that came on an NB. A 5-speed 1B has a 4.3 rear end, a 1.6. They all have 4.3 rear ends. Makes for a very busy engine. So if you put in, say, a 410 or a 3.9, that will slow the engine speed down, give you more speed per RPM. It'll slow the engine down, make everything a little more relaxed, but it will blunt your acceleration. If you have a whole lot of horsepower, you might find yourself blowing through gears so fast or having not enough traction to be able to use what you've got that if you go to a lower number, a taller gear, that will let you, drive that gear out a little bit further. It'll let you hook up a little bit better because it is taking away some of that mechanical advantage over your tires. And so there can be an advantage there. If you're changing your transmission, the 6 speeds, and I'm talking NA and B here, the 6 speeds have a different top gear than the 5 speeds do. So if you want to get the same gear selection or gear range, I guess, you need to change the rear end ratio. So that's why there are several different ratios available. There were 3 different ratios available in the NA and NB in the US market. There were 430s, there were 410s, and there were 3.9s. Not big differences between each of those, but if you put a 3.9 in a 5-speed that used to have a 410, you're going to feel it. It's going to feel longer legged, and it's going to feel a little doggier. But if you've got horsepower, then hey, awesome. The 6 speeds came with 3.9s on the early cars in 2004. They came with a 410, which is a terrible gearing choice in my opinion. Nothing but shifting, all the time. And they put it on a car on the Mazda Speed, which had the lowest red line of any Miata made. It's just terrible setup. Anyway, going to a different rear end ratio on a Mazda Speed, much, much better. A very popular setup is to run a 3.6 with a 6-speed. That gives a 6-speed, you don't have a useless first gear. gives it a nice tall 6th gear. Especially if you got a little bit of horsepower, you can pull that easily. Not a combination ever found in North America. It was used in Europe. Why it was never used in North America, one of the questions, you'll have to ask Mazda, but I suspect it has to do with the low speed limits relatively here versus Europe. Anyhow, Travis, you're twitching. Do we have another question?
So would a custom hardened ring and piston set in a 6-inch VLSD help solve the issues for an STS Miata that can't upgrade to 50? I know, lots of experience.
I love these sort of questions because it's like, I have this problem. How can I solve the problem? So STS Miatas, the autocross class, they are allowed to run a limited slip differential only if they're a 1.6. I think that's how it works. If they're a 1.8, they can't run. They have to run an open. And so the question was, can I make it stronger? Cryo treating maybe, or if you can get a custom-made ring and pinion, which are brutally expensive. I'm sure there are ways to improve the strength of those things. For everyone who is not competing in STS and trying to get that last little bit out, honestly, if I was doing that, I would probably just have a spare in the trailer. But you'll only lose one run if you're fast enough. For everyone else, it makes so much more sense just to go up to the 1.8 because they are so much stronger. You go from a ring and pinion that can be broken with 116 horsepower stock NA, like that one back in the corner, to one that will hold up to 400 horsepower cars. So it's kind of one of those no-brainer things, and they're literally available in junkyards. They are fairly expensive. Mazda diffs on the used market, people know what they're worth. People know what they're good for, and so they are, relative to other cars, they can be surprisingly expensive, but they're still a pretty good deal. Travis.
Would a VSLD swap be much better than an open diff?
So the question is the viscous limited slip better than an open diff? And I would say so. It's not going to be night and day. It's not going to be probably the same effect that I got with that OS Giken where I knocked a second off my kart track time despite the handling change. Will it be better? Yes. Will it be life-changing? No. I mean, there's a reason that the viscous is not viewed as a great solution, generally speaking. It's better than nothing, but only nothing. Make sense? We have so many questions today. Travis, what's now?
So, you mentioned suspension tuning to help prevent wheel hop, which can help prevent diff failure. Can you touch on suspension tuning settings to help this?
Suspension tuning settings to avoid wheel hop. I would start with the shocks. That's a big one. If your shocks are not able, because that's what shocks are meant to do, is get rid of that vibration in the springs, basically. So I would play with shock settings if I had wheel hop. Something else that I know helps is actually running a stiffer rear sway bar. And that seems counterintuitive because really that's only for cornering, but what it does is it forces both wheels to move the same together. So if you have one wheel trying to hop up and down, the other one doesn't want to, the sway bar will help keep that hopping wheel on the ground. So a stiffer rear sway bar, weirdly, will help with wheel hop. Also make sure your bushings are in good shape, because if you ever watch it happening, you'll see that often it's the wheel going forward and back. And it's those front bushings compressing and then releasing, compressing, releasing. So going with a stiffer or even a not completely shagged bushing will probably help there as well. I can tell you this thing will lay perfect stripes. So it's very possible, and it's got standard bushings, very worn standard bushings in it, but it's got good shocks and it's got a good diff, and it doesn't wheel hop whatsoever. So I would concentrate on shock tuning. I think that's the primary thing. And make friends with the drag racer, because there's a guy, he goes by Eliminator. I think on Miata forum. He tells stuff that seems completely implausible, but I know Nick, and I know that he actually has been there and done that. And if you can get his advice on stuff, I don't know if he's still around on the forums, but he used to have a crazy fast Miata that did, it could really hook up off the line. So he actually does know his stuff, even though it sounds completely ridiculous. Do we have more there, Travis? Yes, we have more.
What clutch pack LSD would you recommend from a quality point of view? This person is considering a CAS 1.5.
Okay, so what clutch pack would I recommend from a quality point of view? Flyin Miata carries the OS Gikens. They have been very well proven over the years. In my experience, the OS Giken has been very effective at making my car faster. So I would go with an OS Giken. I do not have a lot of experience with CAS. I cannot comment on their quality level. So I'm afraid I can't really speak to one being better than another. There's not that many available for Miatas, really. It comes down to Kaz, that old Mazda competition one, or the OS Giken. I believe that's pretty much it. And the Gikens are very well proven. So that's one of the things. So I'm going to take a break from asking from poor Travis for a second and talk about ring and pinions again. One of the questions that we get, and a fairly common one, is how can you tell what ring and pinion ratio is in your Miata? Now, this is assuming that you can't just look it up. You know, if you tell me, okay, I've got a 2004 6-speed, I can tell you right away you came from the factory with a 410 in the rear, unless it was a 5-speed, in which case it was a 4.3. If you know that sort of stuff, that's one way to do it. But if you want to actually know, you've found a diff in a junkyard or on your shelf, and you weren't as smart as I were and wrote the actual ratio on the housing, like I apparently did back when I took this thing out of the car. At the time that thing got a V8, so it would have been like 10 years ago. How do you figure it out? And it's actually very, very simple. When you talk about a 410, that's the number of times that the input shaft rotates for the pinion for every turn of the rear wheels, effectively. So you can actually just test that. And if you want to zoom in here, Travis, I put a mark on here so I know where 0 is, and I have a bolt here that we'll use this L as a mark. So I turn this once. We're not back yet. You turn it 2, turn it 3, turn it 4. Ooh, we're almost there, and a little bit. There's a 4.1 or 4.10, just like it says. That was, you know, if you actually measured the degrees, you would find out that I had turned it an extra, what's that, 36 degrees past 12 o'clock. If it was a 4.30, it would have been over here. If it was a 3.9, it wouldn't have made it to 4. So that is literally just turn the input and count the output, and that is your ratio. That's what a 410 means. It's the ratio of number of times the drive shaft turns relative to the wheels. So it's really quite easy to check. There are ways to check if you have access to the ring and pinion. You can look at the number that's stamped on there. You can count the teeth on there because it's just a multiplication of one. You know, divide one by the other, and there's your ratio. But that's a little awkward to do when it's in there. When you can just put it on the counter and just spin the thing. Now back to our questions about what you need to set up for the dial indicator. What can you do without getting into setting up ring and pinions? The relationship between these two gears is very important in terms of how they're set up, the amount of backlash they've got, the amount of the way the tooth engagement looks, because that has a lot of effect on, well, one, your efficiency for my friend who wanted the highly efficient differential, but also the wear over time. If this is set up wrong, it'll wear very quickly. You'll end up with chunks of steel in your differential. Differentials don't like chunks of steel that don't belong to them, and generally sadness. You'll end up with a lot of noise and maybe break something. So it's actually fairly tricky to set up. You've got to set the depth just right. You've got to set the side to side just right. And this is why people like to buy complete units like this, because you can take this out, it's set up, you don't have to screw with it. So the question is, what can you change without messing around with this? Now, I am not a rear end specialist. I will admit that when I need to change a differential, I take it down to the drivetrain shop here in town and say, fix this for me. Apparently this looks a lot like a Toyota rear end, so apparently they're quite familiar with them. But the side seals in the aluminum housing, no problem. Pop the half shafts out, swap them out, they don't do a thing. These are a little more complicated. You've got to take the end off the pinion, and I believe you need to set everything up. There's a crush collar in there that needs to be changed. Side bearings on the diff, you have to take this little thing off, unscrew these. You might be able to get away with those if you can do, say, one at a time. There are some setup guides out there. I think Miata.net has some on how to change this. It's not the sort of thing I've messed with. You see the paint that's on these? That's from the machinist when he set it up. You do that. You put some paint on there, and then you run the. You can see there's some on the pinion as well, and you run it through there, and you see how it wears, and that tells you how they're sitting relative to each other and how happy they are together. So it's definitely a skill. This is one of those things, kind of like setting up piston rings, that sort of thing, that there is very much a skill involved. And if you haven't done it before and you're willing to give it a shot and potentially, wreck a ring and pinion, go for it. Find someone who knows what they're doing, work with them, learn with them. It's sort of thing I would recommend learning, not from YouTube videos or online things, but it's best if you've got someone who knows what they're doing and you get some hands-on tutoring, because there's a lot of stuff that you just learn by doing this over and over and over again. And learning from amateur means you get amateur instruction. So, and if you learn from me, you would definitely get amateur instruction. Travis, do we have any more questions?
No, we're caught up.
We're caught up. Okay, I'm just quickly going through the questions that were given to me ahead of time. So many. Okay. One thing to know when you change that rear end ratio is it will change your speedometer. And we have a gearing calculator on our website. If you go in the technical section, you can sit there and you can play with numbers and say what kind of transmission you have, how big your wheels are, how big your tires are, stuff like that. But one thing to realize is that going from a 410 to a 430, that's about a 5% change. It's going to change your speedometer by about 5%. Going to a higher number like that is going to make your car basically, for a given engine speed, it will go slower, so your speedometer will become optimistic. I'm probably getting that. No, it'll become pessimistic. Optimistic. It'll be optimistic. If you go to a lower ratio, it'll start becoming pessimistic. Lower meaning lower number, or a taller ratio. Put a 3.9 in there and it's going to start getting pessimistic. One thing to know is that Mazda Miata speedometers in the earlier cars, less so in the ND, which is a digital setup, but earlier in the ND, they were optimistic. And I've read that Mazda made them as optimistic as they were allowed by law in order to make the car feel like it was higher performance. Because Mazda was all about the feel of the car, especially in the early days. Like the cams for the 1.6s are designed to be revved out. They're fun. It's not a fast car, but it's a fun car. And the speedometers were made to be a little bit aggressive because of that. So if you do something like take a 1.6 or a car with a 430 in it, you put it in a 410, you'll probably actually correct the speedometer. But if you do want to make sure it's the way the Mazda did it, there's some gears in the transmission that have to be swapped out, little plastic ones, blue ones and purple ones and whatever. And if you get the right combination of those, you can make it, you can bring it back to where it should be for your, so your speedometer's closer. Or what you do is you call up Adam at Rev Limiter and you give him a couple of different measurements and he can print you a custom calibrated speedometer face for your actual speed range, which I think is one of the cleverer ways to deal with it. And he can also, make the top speed 205 miles an hour if you want to, just because little kids look in the car and they see that speedometer, they figure that's how fast your car can go. So there you go, 205 miles an hour just because the speedometer says so. One last question, two more questions that I'm going to cover here. One is how to get the half shafts out of the differential, and this is a hassle because they're held in there with little spring clip, and they're fairly tight. And there was, the Gurus in particular, oh my, you're trying to get the half shaft out of a Guru, almost impossible. So you want to make sure that using tools you have around the shop, the best way to do it is 2 pry bars, one on each side, put a little bit of load on it, and then get a friend to just tap the side of the axle. That short, sharp shock that Pink Floyd talked about, that'll actually help pop it free. It's a two-hander thing, but that will get it out. There is also a tool called an axle popper there's 2 pieces to it. They kind of look like a pickle fork. One's a wedge, one's a more straight piece in there. You put in the straight piece, put the wedge in, hit the end of the wedge, and they'll twing, instant. So gratifying. If you're doing a lot of axle swaps, you'll want to get your hands on one of those things. It'll save you a lot of pain in the ass, a lot of hassle, but it's a very specialized tool. Otherwise, don't try to pry on one side at a time. If you try to pry on one side at a time, you'll never get it out because it'll just wedge itself in sideways. And that little shock on the side makes all the difference. Pops it right out. Are there any other non-Miata diffs that work in Miatas? We talked a little bit about RX7 swaps. That was an old school thing. I haven't heard a lot about RX7 swaps for some time, probably because the supply of RX7s is not getting any greater. There are no differentials that I'm aware of that are straight drop-ins. I'll bet you the rear end shares some stuff in common with the S2000. They've got a bigger spline size. It's the same size as the Mazda Speed. So you might be able to use some S2000 parts in there, or maybe the ring and pinion. Not something I've experimented with because their ratios are not ones that are good for Miatas. Being able to run a 490 or whatever the heck it is they've got in the rear end is not something most Miatas are looking for. They're usually looking for the lower numerical numbers. 3.6s, 3.3 was the holy grail for a long time. There's been multiple attempts to try to get a 3.3 to market. I don't know if it has succeeded yet. I think there might have been a couple of short production runs. There is rumor of a particular Mazda pickup truck that in theory came with a 3.3 from the factory. No one has ever actually found one. Been looking for decades. People have been trying to find that particular truck. I think it's just a myth. But anyway, you're pretty much stuck with Miata parts for interchange. Do we have any last questions, Travis, before we go?
I don't think so. Mostly missed.
Okay, well, I'm going to call that it. If you do have any questions after this is not live anymore, which will be very, very soon, Please put the questions in the comments. We will answer them in the comments, whether you're watching on Facebook, on YouTube, or whatever we're watching in 2032. Thanks for your attention. If you have any ideas for future videos that you want to see, any topics you want us to cover, then please throw them in the comments as well. We love to hear from you. And otherwise, my name is Keith Tanner from Flyin Miata. Thanks for watching.